Okay, today we got a hard problem. Find all people with secrets. So we got n people, and then they have some meetings. A person can be at multiple meetings at the same time, right? First, we give a secret to the first person, which I guess is indexed from 0. No, it's not. That's weird. Person 0. Oh, person 0 has the secret, and it shares it with first person at time 0. Okay. So what that's such a stupid setup. Okay, and then you share the secrets when you are in a meeting immediately. So if 2 is with 3 at 5 and 3 is with 4 at 5 and only 2 knows the secret, then instantaneously 2 and 3 also know it. And we should just say all people that have it. So my idea is that we simply sort the edges by time, and we yeah, so no, we don't sort the edges by time. Maybe union find. I think union find. That's weird. So essentially we start at first person, right? And then we do what? I mean, if a meeting takes place and neither of them know it, then it doesn't propagate. So essentially we start from person 0, and then we keep the current time, and we discard all edges with smaller time, and yeah, I guess that's it. So essentially we do some sort of like a we put edges inside, and we cannot put the ones with, if we keep like last process time. So initially we put all edges of first person, and then we put start from, okay, so put all edges, the end vertices with times into a priority queue, iterate over all, okay, for each edge iterate over all neighbors, and if and there, no, for each edge iterates all neighbors of the ending vertex, and if edge has time after the current vertices, after or at the same time as the current vertex, if edge has time after or at the same time as the current edge, then we pass, then we put it into the queue, I guess. So I just want to write it down before I think about it, and if I write it on a paper you won't see shit. So okay, so I guess let's do it. So priority queue int vector int greater vector int pq push 0 pq push. I forget this every time. Return pq top. Let's see which one that will be. Like this. 0. Okay, so I remember that correctly. So and now we need a graph. So let's construct the graph. Vector of pair int arch of n, and then for auto m in meetings arch m0 push back m1 m2 and arch m1 push back m0 m2. Fair enough. So that's our answer. Okay, and then for const auto should be also const auto and the reference so that it compiles faster. So this is y. Actually, yeah. So let's call it y, and time in adjacency matrix of first person, and then pq push, and then we push like time y first person, so we know which edge to skip. And I think that's it. So ans push 1 0 okay, now while not pq empty. This seems way too simple, but whatever. So int time y x tie y x to pq top. Will this compile? Probably not, because no viable. Okay, that won't work. So const auto int t pq top 0 y pq top 1 x pq top 1. But wait, that's weird, because should take all the edges and then like do a traversal on them, because this way I could theoretically skip some of them. Like let's say I would have edge like 1, 2 and 2, 3 at time 1, right? And then I would first process this, but none of these guys know it. Yeah, so I need to take in the edges, do a DFS on them, and then continue. Damn, that sucks. So I just order edges and then so it really is just union, fine, and you keep what is in what component. Okay, so I'm just stupid. So times are what? Up to 10 to 5. But I guess I can like vector int meeting. Of course we need 1000 union find implementation. Union find int and vector int, and now we need a parent size, and then we also need like nose and union find int n parent of n size of n1 and nose of n, and then iota var begin var end 0 if x bar x return bar x. Okay, we could do like int root is find parent x, then nose x, or with nose root var x root, and we return that. So essentially we should be able to do this, I think, and then void unite parent of y is x. And then we want to do like nose x nose y is equal to nose x or nose y, This will for sure work. It will not work at all, bruh. Sort meetings begin meetings and int x int y. Okay, the dog always barking, so return meetings, no, x2, y2. So, and after we sort them, then we go into, meeting size, then we don't do anything. While j is under meeting size and meetings I2 meetings j2, then we want to put this into union find. So we want to do like unite union find uf of n people, and uf knows first person yes, and uf knows 0, they know, right? And then we simply unite meetings j0, meetings j1, and then finally we go through vector int ans and for int I, and if uf knows uf find of I ans push back I return answer. Oh my god, what is that? Vector int, let's call it like const missing the semicolon, and then uf unite so 0 knows it. Okay, so union find doesn't work. I'm so stupid. So stupidly. So maybe that approach worked, but that's so stupid. So instead of this, we just do a DFS on the edges that we have just added. And just update those. Like we mark the visited vertices and nodes, and then we return. And then we set all of them if at least one of them knows, and then we move on. That sucks, brother. But okay. So I sort the meetings, right? Now for each edge. Nose, 0, nose, first person, and then for all of these edges, right, with vector int int x meetings j0 y meetings j1 z meetings j2. It's time, but x push back y y push back x time y time okay. And then we do push back x, but this push back y, and then we just iterate over. So for int v in vertices, and then we want to DFS v component, so component, right, and we pass DFS with v and int time meetings I2. So only over these vertices. Int any is this, and now if any, then for auto comp vertex component knows comp vertex is true. And then we need some sort of DFS, so function int DFS and then we wanna do int sur knows, or like comp knows is knows v for int u in I mean, we can just store the parent, but no, we cannot. That's not enough because it's not a tree. So we need some sort of for int u in arch this if const auto u team, and now if not this count u and team t, then comp knows, or with dfs u t, and then return comp knows. Should work. So this is undeclared. Oh, that's great. That is fantastic. So we need to pass in like this, and also the components. It's invisited, so whatever. Unordered set int visited. I mean, it's a hash set, so it's shit, but oh my days. Unordered set int boom. Sorry, I did a sneeze. Memory limit exceeded. Hell yeah. Okay. And then I guess let's take it here. Private int. Well then, vector pair int arch mouse vector int mouse we need to pass by a reference so it's not copied every time. Memory limit exceeded. You fucking kidding? What the hell, man? J++ still not there. Okay, now it works. That should work. It's quite like TLE on half the cases. Oh yeah, because probably I need like set unordered set of these. Okay. Use test case. Should run fast, no? Why is it like, can't I do DFS or what, bro? I mean, this means that everyone knows it, right? Yes. Okay, so this just means that everyone knows it. Like, what's so slow about this, bruh? One, two, three, 4, 5, 6, 7. So 10 million, so 1 million lines. Why is that? Oh, I know. I'm so dumb. When I'm not passing in component or what? Like this. Okay. I was running DFS every time, which is kind of bad. But okay. If not, discount W. I don't even have to call anything. Okay, let's see. Still slow, seems like, for some reason. In free test cases. So I have to remove duplicates. You kidding, bruv? Should pass, I mean slower, but should pass. No, it will not pass. Yeah, no, this should be like ordered map int, right? And now if hx not hx count y, and if not hx count y, if not hx count y, or hxy over time, then hxy hyx time Why wrong answer when I just run it on the lower ones? Yeah, because you can take the cheaper one only. Some flat fill should work. Okay, I guess back to flat fill. So we saw the meetings, we don't do that. Priority. Const auto meeting in meetings. PQ push. And we'll do it like this, so PQ push -m2 -m0 m1, and then wonder though, why was that slow? I don't understand what it cannot do on this one. Like, is there a huge number of edges on there or what? Oh, because it has to go through all the previous edges. Like this. Okay. This maybe passes. Okay, I mean it's very slow, but whatever, I guess. We have n people. Okay. Mm-hmm. Why wouldn't they just do it in both times? Is that like absolutely stupid? Seems quite simple, you know. Priority queue. In place this, visit it. Pick up off if it's visited, then visit it through, and then yeah, I wanted to do something like that, but probably would be faster. BFS on time scale. Yeah, they do this, so that's m log m plus n union find with reset. Oh my days. Okay, I mean, how would you do a reset, bro? What? Holy. How is that possible, brother? Rank heuristic. You could just swap in case of this, whatever. Connected, reset, parent of x is x. Okay, so you sort meetings, same time meetings. Okay, unite first person 0, and then if anyone knows the secret, if not, graph connected to 0. That's a good idea, brother. That's a good idea. That's good. Okay. Yeah, I mean, my approach is like the third one, so let's just quickly describe it and go do something else, because today I'm not gonna be on time with anything. So let's call it like time-based DFS O of m log m plus n. So intuition. Let's look at all meetings at time t. The people meeting make up a graph, and if at least knows the secret, everyone in the component should know. Will know the secret after we process the meetings by increasing time and only do the components checking based on the current times graph. It will be good enough. First, we sort the meetings by time and then iterate over meetings, gathering the ones with same time, and for each of them we add the respective edges to the end of each vertex's adjacency list with the time of the meeting also, and then So we first sort the meetings by time and then iterate over meetings, gathering the ones with same time, and for each then we add the respective edges to the end of each vertex and adjacency list with the time of the meeting also, and then finally we do a DFS over vertices of the current time meetings, and in the DFS we iterat over the adjacency list backwards and finish the iteration when we process all edges of the current time. So we to avoid of n squared complexity. Finally, if any of the vertices we mark the components vertices in a list, and after the DFS, if any of the vertices knew the secret, we tell the secret to everyone in the component. Finally, we return people with who know the secret. Time complexity m log m plus n. Since we first sort the meetings, then and then eventually add all the vertice meetings in OM log m, then eventually add all the vertices, all the meetings, to the adjacency list, which takes OM, and finally do the DFS on ON vertices and OM edges in total. Which takes n plus m for all times combined, but OM is asymptotically less than m log m. We arrive at our final time complexity of OM log m plus n. Space complexity is O of n plus m, since we store the edges in the since we store the meetings in the adjacency list, and we also have a visited set, which can have at most on for each time which can have at most ON vertices inside. Okay, goodbye.